Hi, this is the Tempter podcast where we discuss embedded Linux, IoT development, and anything else we might find interesting. Your host is Raj, and today I'm joined with Cliff Brake. Cliff,
Hi, Kim.
how are you, Cliff?
Yeah, doing well. How about you?
I'm doing fine. So Cliff is a Yo distro creator, and he's a very prolific contributor to open source. And today we are going to talk to Cliff about his experiences. Cliff has been very effective in several communities, including open source communities like Open Embedded, and he is trying to create a new community for IoT, which is called Simple IoT. So I'm very excited, and we'll hear more about that in this podcast. So welcome, Cliff, again. And how do you feel today? And what would you like to say about this?
Yeah, looking forward to the discussion, and it's always a learning experience, so things I'm very interested in.
So Cliff, you have been involved in open source for many, many years, and so it would be interesting to know how did you get into open source, and what inspired you to get into open source, and what have been your learning so far?
Yeah, I've been working in product development about 27 years now, and trained as an electrical engineer. And years ago, one of my coworkers introduced me to Red Hat Linux around when it was first released. So that's kind of what kickstarted the Linux movement, at least what I'm familiar with. And a number of us were installing this box distribution that we bought at the local computer store on our PCs. And I had been using Unix systems in various forms at school and work for several years at that point. So this was very interesting to have a version of Linux, which was like Unix, that I could run on a PC and do many of the same things. So that was kind of my first introduction to Linux, which really helped start the open source movement, it seems.
So was it like Red Hat Linux 6 or something like that you started with? Or?
I can't remember the number, but I think it was in the mid-90s, so one of those early versions.
I see. And I'm sure that besides Red Hat Linux, you also kind of then ventured into other distro hopping and things like that, I'm sure.
Yes, over the years I've used several distros, including Gentoo for several years. So lately I've been running Arch Linux, which fits my needs well. It's very well maintained, very, very reliable. But it's also a rolling distribution, which gives us the latest versions of everything. And as a developer, I find that very useful to always have the latest tools or libraries available. So I like that a lot.
Nice. So how did you get into Open Embedded, and then I think we'll get to how did you get to create Yo distro? But I know that you've been involved in Open Embedded in various forms for several years, and so what was your point where you kind of started with the project, and then how do you use it? Which parts of this have you been involved in, and various other aspects?
Like I said, I've been mostly doing product development, so that's kind of my perspective. At one point, I worked for a company that offered product development services, and at a previous company, we had embedded Linux on a PC processor inside a medical printer. So that was kind of my first time I used Linux in an embedded system. So then we were helping people develop products. Some of the early processors, like the StrongArm SA1100, and I think that was one of the first processors that would really made it possible to run Linux.
Yeah, I remember that. Yeah, so I think that was really good processor that got into the PDAs as well, right?
That kind of kickstarted PDAs like the Compaq, IPAC, and various devices like that. So about the time those devices started coming out, running Windows, Microsoft's OS, Windows CE, and various forms of that, a lot of people were interested in running Linux on these devices, and there was the Sharp Zaurus and several other devices at the time. So a community kind of built up around that, some tooling to build these embedded Linux distributions or images. And Open Embedded kind of emerged as a very nice tool at the time and has continued for a number of years now. So as we were developing products with these strong arm processors and then like the PXA 270 that followed and various other processors, some of our customers wanted Linux, and that kind of got me into the open embedded scene. That's kind of pretty much been involved from the start back when it was created. So lots changed, but it's a lot still the same too. So
yeah, I think there was a time back when it started off of Gentoo, I believe, and then it adopted some portions of how Buildroot was doing things like packages and stuff, and then evolved into a thing of its own. Can you recount like a couple of areas where you thought that project was successful over the period of years and to garner the community and in general making like project useful for a lot of others?
Yeah, just thinking back now, I guess what really impressed me about the Open Embedded project was it had kind of a nice structure and consistency about it. The organization of packages, classes, recipes, and then the various meta layers and the kernel tooling and the ability to fetch from Git repos and build our custom applications and sources, and also the ability to modify existing packages. That was all very critical to build products in a controlled way. Before that, we would, the typical process was to find somebody who had kind of put together an image, a rootfs image by hand, and then you'd kind of copy some stuff into it, kind of build up a tool chain using, that process just wasn't maintainable or sustainable for product development where, you need to run these builds over a long life cycle of 5 years. Things are continually changing, requirements are changing. And the fact that with Open Embedded, we could build everything from scratch, we had full control of it. And it was in a very controlled, predictable tool. This provided a huge amount of value to what we were doing.
So yeah, that's quite interesting. And now I think I'm interested to talk about your projects, specifically the two projects, actually the open source that you have created recently. It's one of them is the Yo distro, and the other one is the Simple IoT project. So could you go into what basically is behind these projects and why you thought this project should be created? So essentially, they do kind of like fit into IoT and embedded Linux kind of world, and they go hand in hand. So what are the parallels between them? And so it would be interesting to know that.
I guess maybe I'll back up just for 1 second and talk about why we use Linux and embedded systems to start with. And it's typically when you're processing significant amounts of data or you're presenting complex user interfaces with say, a touchscreen LCD, or you're communicating data over networks that's a little more complex than, say, a few variables. So in all these scenarios, we reach for a complex system like Linux, which has the features we need. And as I was using Open Embedded on projects, we were kind of doing the same thing over and over. And over time, we developed some tooling and a very thin wrapper around Open Embedded that kind of helped us automate a few things. And we also came up with a directory structure that made a lot of sense. It made searching for things easy. It made capturing changes in Git easy. And this became what we called an OE build template that I used for years. And then others like yourself kind of contributed and used it as well. And then at one point we were thinking about what to do with this OE build template. And we thought it might be good to spin it off as kind of a standalone project. And we named it the Yo distribution. So that's kind of where it's come from. It's evolved over a number of years, but we really try to emphasize simplicity. We try to keep it thin and light, and really tailor really tailor it to help people who are developing products do their job easier, faster. So that's
Mm-hmm.
kind of the story behind OE. So the Simple IoT project kind of came about in the same way. We've been doing IoT for years before they called it IoT. Basically, it's collecting data and sending it over networks from sensors and various devices. So again, there's these common things we're doing on most projects. There's a user management aspect. There's group management. There's most projects. You're deploying a number of devices, and certain people need access to a subset of those devices. And then those people are usually organized in groups. They may belong to one company or
Mm-hmm.
one organization. The code to manage a cellular modem, that
Mm-hmm.
tends to be the same from project to project. Another thing we recently added was Modbus support. That's very general and reusable.
Mm-hmm.
So both these projects kind of are a collection of best practices and code and tooling from real world projects that we've just kind of collected and organized in a reusable fashion.
Mm-hmm. Nice. Yeah. So I was looking through the Simple IoT project, and it seems to be written in Go language. Is that right?
Yes, that's right. We tend to use that where we can these days for a number of reasons. It works really well in embedded Linux edge devices because it's a very stable, reliable language. It's very efficient. The binaries are reasonably small, and
Mm-hmm.
it's just a pleasure to work with. And likewise on the cloud side, all the same things still apply there. So it's easy to deploy,
Mm-hmm.
and really has made this, make creating these systems a lot easier.
Mm-hmm. So I talked to several engineers and architects who do edge development or sort of embedded development, and there is this hesitancy still that they Go language is kind of classified as a language that has more appeal towards web programming and maybe networking or some sort, but it's essentially being classified as a server programming language. So what's your take on that? Like,
Mm-hmm.
you know, I think you have basically used it, not everything server, basically you have used it for everything else. So
Yes.
it's interesting to know from you that is that notion correct, or is there something that we can learn from that? And so that'll be really interesting to know that how does Go scale into this
Mm-hmm.
edge devices, so to speak, right?
Yeah, I think there's an analogy to Linux that I'll make. The Linux kernel is a very efficient, reliable, well-written piece of software that has been deployed into many, many servers. That's probably where it's been the most successful. At
Mm-hmm.
least initially, it was a very successful server operating system. And the reasons for that is it's reliable, it's secure, and if you're deploying into a data center with servers, you want it to be very efficient too, because then it requires less hardware, less
Mm-hmm.
electricity. For the same reason that Linux scales well into the server and cloud space, also makes it an excellent fit in the embedded space because it's efficient, relatively small, doesn't take a lot of resources. When Google created the Go language, they had many of the same constraints in mind. When they deploy something into their infrastructure, they want it to use the least amount of resources as possible, and they want it to be efficient. So they created it for the cloud or for the servers, but the constraints they designed it under also make it very applicable to embedded Linux. And like I said, a typical Go application is around 10 megabytes in size. The binary has
Mm-hmm.
everything embedded in the statically linked embedded in it. So it's 10 megabytes, that is a chunk of memory, but in a modern embedded Linux system, that's pretty insignificant when you compare it to other application stacks like Python or Node.js. And
Right.
even C, the libraries can quickly add up to tens of megabytes. So,
Yep. Yep. So now the projects are out there. So what are some areas of you're looking for contributions to these projects, and what would you advise if someone was interested in contributing to these projects?
Well, I think the best way to contribute to something is if you use it and find it useful, you're naturally set up to be a contributor.
Hmm.
Like I said, we've used both these projects,
Hmm.
and I know you as a maintainer find the Yo distribution useful for your work in maintaining all
Yep.
the various open embedded layers and bits that you maintain. So we think it's generally pretty useful. The best way to contribute something is to be a user. I remember a comment by Matt Mullenweg, who's one of the founding developers of WordPress, is his advice for open source projects is be your most passionate user. So, most things get done when you scratch your own itch, or however they say that. So
Mm, very well said.
and then, we just use a standard GitHub flow. So open issues or pull requests.
Hmm. So I know that there are several ways people work, and you are very heavily development focused as well. And I'm sure that listeners would like to know a few tips from you, from your daily work life, to if you can share a few tips and tricks that you deploy often doing development, debugging, or any other sort of software activities.
Mm-hmm. Yeah, I've run Linux as my personal computer OS for years, and I think it's great. I've also run Mac OS at times, and
Hmm.
but one thing I think if you're going to be an embedded Linux developer, it really helps if you run Linux on your computer as well, because it teaches you a lot. And
Hmm.
I just think it really, Linux is Linux, whether it's on the server or desktop or embedded. So the more you use it, the better you'll be with all the different aspects of it.
Hmm.
And one thing I've kind of learned from the Go community, and then subsequently in JavaScript and Elm communities, is the value of code formatting tools. And this
Hmm.
this kind of surprised me, but in the Go community, there's a Go format tool which formats your code, and it's been integrated into all the editors. Looking back, it's just surprising how much value that adds, that you can just write your code and don't have to worry too much about formatting. When you save it, boom, it just is magically formatted very nicely.
Right.
So once I got used to that in the Go, with Go, I just find solutions for all the languages I program. Even Bash, there's tools now to format Bash scripts, and they're very
Hmm.
powerful. They make suggestions. They help you clean things up. They find errors, and it's just a really a nice. It's a little thing, but it has a big impact, I feel,
Hmm.
for
Hmm.
developer happiness. So
Yeah.
I use NeoVim and VS Code some.
Hmm. Yeah. Yeah. I think this is really good. And actually, that reminds me that recently my son is learning Go, and, he was using Visual Studio Code, and so he used a function, in fact, from math library, and it added math to import automatically.
Mm-hmm. Yeah, Go
And
imports, right?
yeah, and then he stopped using the format package, and it deleted it automatically. And I
Mm-hmm.
found that very useful because in C, 30% of the time is spent in parsing, right?
Yeah.
And one of the reason is that it's the includes and includes and includes that it is parsing in your C
Mm-hmm.
program. And so eventually, like if you have huge programs, then there's a significant amount of time that is now being spent on these includes and whatnot, right? So what I found is, and it just occurred to me because I'm not a deep Go programmer myself, but I looked at it and I said it's the right thing because they will keep it, neat and nice, and only include the things that are needed, and it's really, really useful. So,
Yeah, that's just huge. I mean,
mhm.
after you get used to programming in Go with this type of tooling, it's really hard to go back to C++
Mm,
and separate header files and managing all that. Like you said, it's,
yeah,
computers should really be doing these things for us at this point.
right. So, So I know that you have a long body of experience, and anything you learned over the period where you like to tell people, hey, don't do this.
Yeah. Well, I guess, just kind of on the embedded Linux side, I've seen people trying to deploy Node.js applications to embedded Linux several times, and
Hmm.
that's really proven to be a pretty difficult task for a number of reasons. But oftentimes, Node.js packages, they link to C libraries, and they have all these kind of handcrafted ways to build C stuff into Node.js packages.
Hmm.
And then whenever you try to cross compile that stuff, it's a mess. So,
Hmm.
and plus the dependencies tend to really explode in the Node.js applications,
Hmm.
because every package can include its own chain of dependencies. So there's no sharing of dependencies. And on a server or on a workstation, that's not a huge deal. But in an embedded system, you can quickly rack up tens of megabytes of dependencies. So I would strongly encourage looking at Go, if you're going to be deploying that type of application to embedded Linux. And then the other
Hmm.
other thing that came to mind when you asked that is, don't wait too long to ship your first version of anything, whether it be a project or a product. Or I think many of us can get carried away with future proofing or perfecting, and
Right.
upfront planning and design is important, but it's also important to get something out there and get feedback, because often one of the biggest challenges in a product is figuring out what's actually needed and how users are actually going to use it and what they really need. So
Yeah.
one of my favorite articles is titled "Iterate Hardware Like Software," and maybe we can provide a link to that in the show notes. But
Hmm.
it's a neat article, and it kind of captures some of these thoughts.
Nice. Yeah. Yeah. I think I agree with both your points, I think. And so, are there some of your favorite books that you like to share with us, or any podcasts you listen to, or blogs you read regularly?
Yeah, I really like podcasts. They provide insight into people and projects that you don't get any other way, I found, and I'm not sure why that is, but it seems like the discussion format sometimes this informal type format reaches a little deeper into the whys and hows than something more formal like a blog
Hmm.
or other types of media.
Hmm.
So I like the changelog family of podcasts, but there's so many good ones, and personally, I just kind of listen and read a smattering of different things. So I don't know that I'm reading a book right now called Drive by Daniel Pink, and I think it's excellent, definitely worthy
Hmm.
of consideration.
Hmm.
So,
Yes. So, do you like what category of books do you generally prefer to read?
yeah, I suppose I enjoy reading about technology, and then also kind of like this Drive book. It talks about company culture or just what motivates people,
Hmm.
why certain organizations succeed, why others don't. So
Yeah.
that aspect really interests me. One thing I really like about open source is just the collaborative nature of
Yes.
the projects, and I think there's a lot we can all learn from that. It's very successful,
Yeah.
and yeah, I just enjoy learning about that aspect of open source.
Right. Right. Yeah, I think the intrinsic motivation, so most of that is common that you will find in a lot of open source projects, and it's fascinating to me as well.
Hmm.
So, so yeah, any particular upcoming technology that you're looking keenly on or that interests you? Would you like to share a few thoughts about those?
Yeah, I don't know that I don't consider myself much of a visionary or prophet, if you will, but one thing I do believe is the future is simplicity. Simple things are really gonna be the path forward in a lot of areas, and I think
Mhm.
programming languages like Go and Elm have kind of demonstrated that. And then there's one thing that kind of comes to mind with embedded Linux, it seems like the tooling is still way too complex, and some of the abstractions are I think with Yocto or Open Embedded, one of the things that's a little frustrating for a lot of users is the stack traces when something goes wrong. It's a
Yeah.
bunch of undecipherable Python stuff that just is very difficult to wade through. So I guess that's kind of where as I get older, that's kind of where my preference is, and where I believe is any way we can make things simpler will provide big benefits. The other thing that's kind of interesting from a product development perspective is just the new ways to prototype hardware, where you don't talk to anybody, you just send your design files and they produce a printed circuit board, assemble it at fairly low cost. Seed Studio and Macrofab are both companies doing this. I'm sure there's others, but this is really gonna change the way we develop products, and that we can iterate much faster at very low cost. So that's very interesting to me as well.
Yeah. So do you think that the hardware development would be as iterative, as fast as software? I assume, right?
Yeah, it'll never be quite as fast, but it's changing. For $50, you can get a new round of prototypes built, and
Right.
it really changes things from say 10 years back, where it would be thousands and thousands of dollars just to do even a low volume run of prototypes. So
Yeah, I think there used to be like alpha release party and beta, and then taping parties, right? And these taping parties were spread across, I think, 6 months or something. So yeah, I think the total time was really, really huge for a new chip to come out, for example.
Sure. Yeah.
So I think it was really interesting to talk to you, Cliff, about various technologies and your history with open source, and seeding the projects that you've done for open source, and of course, few pearls of advice that you offered. Thank you very much. Any final thoughts you have for our listeners today?
No, I appreciate the opportunity, and look forward to engaging with various people as they find interesting projects. And I'm sure there'll be a lot of interesting things going on in the future. So, yeah.
All right. With that note, thank you, Cliff, very much. And we'll be back with another episode of Tempter soon. Thank you very much for listening to us. Thank you.
Okay. Yep. Take care.